Everyone, it's September 18th. Alright, yesterday was pretty bad. I mean, not only did we not solve the problem, but also took an hour and 40 minutes. Let's redeem it today. But also something not so good happening today. I think I was going the wrong direction compared to what my manager was expecting, so there's a little bit of misalignment. And I think I put too much emphasis on trying to pick up C++. I think I don't even have to do it, at least for now. No C++ for now. So, yeah, it happens, miscommunication. Need to talk to my manager more often to make sure that we're aligned in what we're trying to do. All right, anyway, old problem. Let's see if we can do it this time. Man, yesterday was just so bad. All right. Given a string of numbers and operators, return all possible results from computing all the different possible ways to group numbers and operators. Holy crap. So basically, So, oh my god, let me think. So all different ways to put parentheses, right? Which just means how do you compute it? Usually when you do this, usually it's a stack. You put 2 in, and then you put minus in, right? And then you can say I'll do 2 minus whatever the result. So you will run the result and you get it and you do 2 minus, right? So for each one, it's either you don't compute it, you compute this, or let's say you compute with the next value. When you compute the next value, and then you get a new value, and then you put the next one in. So that was the 2, but I was wondering if we have a much more comprehensive example, things will be different. So if I have 2, 3, 4, and 5, and look at the 2. So I can do this first, or 2 whatever 3 minus 4 times 5, right? That's kind of the 2 things you can do, which I think is correct, because you can see that's 2 times whatever. This is 2 times 3 first. This basically is 2 times 3 first, right? And this, yeah, I think they're just 2 ways, right? So I can say I'll do 2 times 3 first, okay? So basically it converts to 6 minus 4 times 5, right? So basically it's this, and this is going to be 2 times, so we are solving 3 minus 4 times 5. Now I wonder, how are we going to translate this? No, we just keep going, right? So yeah, so it's 2 times 3. So this basically we bifurcate into these 2, and then we do 6. So 6 can do, 6 minus. Okay, let me just do it. That would be 6 minus 4, right? Times 5, or 6 minus 4 times 5. Right, so this one will be 2 times 5, and then that will be 10. There's nothing more. And this is also the same, that's 20, so this is minus 14, right? So that's on that side. So on this side, we can do 3 minus 4 times 5, right? Or 3 minus 4 times 5, right? So this will go to, that's 20 minus 17. This will go to minus 5, but we have the times 2, which get us minus 34, and minus 10. So we're missing, we have minus 14, minus 34, minus 14, minus 10, plus 10. We're missing 1. We're missing a minus 10. Yeah, we definitely get this. How about this? Did we get this? Oh. Some of them have duplicated. So these two are the same. They're the same way, but it's a different way of adding parentheses. So what are the difference? So this is, so we always put a parenthesis on the outside, right? And then this position, we put the parentheses here. And then so 2 times this times this. So this is put parentheses here. Now that is tough to do. So I can get all the values, but this is 2 different ways to organize it. So maybe we need to okay, so 2, 3, 4, 5, right? And the outermost, maybe we're able to enumerate all the ways that we can put parentheses. So if we want to enumerate all the way to put parentheses, we can say, okay, we put parentheses here, right? And it has to be including an operator. So that's one way, right? That's 2 ways, and that's 3 ways. That's for 2, right? Involving 2, 3 ways. And for each, right, 2, 3, 4, 2, 3, 4, 5. Right, for this, I can put this. What is the last one? Last one's like, doesn't mean anything, does it? Yeah, we can say, if I do this, give me all different things we can do in the remaining, right? So here, hold on, let me think again. No, it should be 2, and then we do 3, 4, 5. Right, so 2 times 3, 4, 5. Whatever 3, 4, 5 can do, or 2 times 3. I still think this is right. 2 times 3, and then minus 4 times 5. Whatever we can do here. So 2 times 4, 2 times 3, minus 4 times 5. So minus 4 times 5, what type of results can we get? Because 2 times 3, it's basically 6 minus 4 and 5, right? So I still think these are the 2 different. So we now do 6 minus 4 and 5. And this is a minus. Yeah, minus and then times. And this is going to be 6 minus 4, or 6 minus 4 times 5. Right, so this is going to be 10. This is going to be minus 14. So that's the 10 and minus 14. Right, we get these. So issue is with this. Right, how do we handle this? So you can see 2 times, that's a 3 minus this plus 3 by itself. Right, that we get. This is 3 minus 4 first. What is this? This is 3 minus 4 by itself. So basically, we have this situation, right? And this, we're saying is 2 times, when we get these two together, minus 1, right, times 5. And here we have 2 times this, or 2 times minus 1 times 5. Both are minus 10. So how do we rationalize? It's still, it is the same idea, right? It is the same idea, which means when we say 2 times this, it's not necessarily 2 times this. It's when you handle this part, right? We say we can do this first, then we will, this will be minus 1 times 5, right? But we have a 2 at the front. So when we do this, and in fact, if we do 3 and 4, 5, 3 minus 4 times 5, right? So that's essentially 3 minus 20. So we have 2 times 3 minus 20. Then we have like 2 different ways to do this. We can say 2 times 3 but that is the same setup as before. Or 2 times 3 minus 20. Hold on, let me do it one more time. 2, 3 minus 4 times 5, right? So I say I can do 2, get 2 out. Then I'll have 3 minus 4 times 5. Okay? And then 3 minus 4 times out, we can say 3 come out. We have minus 4. Now, what if we do expression length? So the shortest expression is 2. Right? The shortest expression is 2. I'm pretty sure that should be the case. I'm actually not quite sure if this is even correct. I think it's not correct. Alright, so I can do this, right? Oh, damn. Yeah, I have a lot of questions. So yeah, this is a 1, but if I say this should be an error. Yep. So at least I have, if it's Yeah, if it's, oh, okay, there are a couple of things, because that's a string, right? We need to split it. I think I can split it using this. Oh, but if you split it, you don't know. So, huh. It'd be nice if it's just like a string, yeah. Okay, we figure that out later. So if I do this with 3, because with 3 is always only 2 ways, right? So this will give you 2 ways. No, we shouldn't. We just, with 3, right, with 3, always we can, minus 3, we can condense it down to minus 1 times 5, or 3 minus 20, right? We'll condense it down to, so we do this, and then we come back to this. Now we have 2 times minus 1. Hold on, we can remove minus. So 2 times minus 1 times 5, and 2 times 3 minus 20. So for this, also 2, right? We have 2 ways. One is become minus 2 times 5, or 2 times minus 5, right? And the other is 6 times minus 6 minus 20, or 2 times minus 17. Right, now we get, when this goes out, we do this. So this gives you minus 10, minus 14, and minus 34. And the other way is just group those together. So now we have 6 minus 4 and times 5. 6 basically plus minus 4, right? 6 and times 5. And then for this, there's always, so one is 2, we just return 2 results. This is going to be 10 or minus 14, right? So minus 14 again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Shoot, can't do it that way. Because this minus 14 is the same way as we do minus 14 here. It's the same parentheses. That's the difficult part. It's the same parentheses. So the other way is we are missing one parentheses, and this way is we have the same parentheses. So that analysis also doesn't work. Holy crap. Different ways of putting parentheses to group numbers in different ways. I mean, group numbers in different ways. I still don't understand. Yeah, I mean, this is grouping numbers in different ways, right? This does count group numbers in different ways. Hold on, let me do it one more time. 2, 3, minus 4, 5. Okay? So, if we just consider grouping, I say I group these together. Okay? Then what? Well, if I group these together, then this one becomes basically 6 minus 4, 5. Right? Then I can say I can group these. Yeah, and I will say I can group these together, and this gives you minus 10. No, because it gives you 10. Or I can group these together, This gives you minus 14, right? Yeah, you group this together, it becomes three numbers. Three numbers will give you two values, right? For sure. If it's three numbers, it give you two values. So that's the first. Okay, now I can say, again, the same thing. So what if I group this together? But then you have two coming out of it. Right, so you have four. It's just how is these two? It's it's not grouping. It's so you can say this gives me 2 because this has some value, this has some value, right? So you can say minus 4 times 5. You can say we don't group 2, we group this together. And this gives you 2 values as well. Then we have 6, but the answer is 5. Damn. I doubt I can redeem myself today. This is weird. So why will we have this? I mean, it's minus 10, right? It's minus 10. So minus 10 I do hit twice. It's something. Because I do this, and then I do this times 5. This I do this times 5. Yeah, that's why these two are the same. Huh. So if I say I will run all the possible ways with 2 and 3 grouped together. If 2 and 3 grouped together and I do all of them, then we're done. Okay, so 2 and 3 cannot be grouped together. And then I say, now how about so 2 and 3 cannot be grouped together. So when we do this, so 2 and 3 cannot be grouped together. Then we have to have, hold on, so we say 2 and 3 grouped together. Okay, this one. Try it again. 2, 3 minus 4 times 5, right? So we say 2, 3 grouped together. So now 2 and 3 cannot group together. So I have to put a parentheses, right? And when 2 and 3 are not grouped together, but this produces only 2 results. It's minus 34 and minus 10. But a minus 10 has 2 ways of grouping. In both is you have to have a group, right? Now the difference is when, so both are doing this grouping. Huh. Maybe it's 2, 3 grouped together. 3 minus 4 grouped together. Oh, and 3 minus 4 grouped together, we do have 2 results. 2 minus 10s. And then we have minus 4 and 5 grouped together. But then we have 6. Right, we have 6. But the answer is not 6. Yeah, because 4, 5, oh, because 4, 5 already grouped together. Oh. So this one will give us minus 10, right? And we have, oh, I can't even do minus 4 because I can do 4 times 5 grouped together. Oh, it's the same. Right, minus 4 times 5 grouped together. But this one already does, so I cannot do that. So I only can add. Right, so it will be 2 times 3 is minus 20. Right? So if I do this, minus 14 will be repeated. Lord, why is this so hard? Yeah, I can see this. This is, let's say, 4, 5 grouped together. We have 2. 3, 4 grouped together. We have 2. 2, 3 grouped together. We only have 1 because the other one's already handled. How do you differentiate them? Well, technically, if you can generate, can we generate? I'm kind of thinking maybe we need to generate. Can we generate all the parentheses? Right, for 3, 4, 5. Therefore, before 4 I can pull 1, or I don't pull 1. In front, I pull 1 after. So 4, I have 2 choices. Okay, so how about 3? I can also have 2 choices, right? So we can do, instead of putting in front, I put in back. Alright, so 4, I can do this, or I can do this. That's still only 4. Well, the only difference I can say is, in this case, we will be generating 2 numbers. Right, these are 2 numbers, so no further. And this will be generating this is a number, do another number, so it's like 2 numbers. So these two are always 2 numbers, but this is slightly different. The middle situation is different because the middle situation is generating 3 numbers, so that will provide a double. So okay, that kind of makes sense. So what you're trying to say, so eventually, so we do 3 has 2 ways. But there is duplicate. I don't know. Man, is this a tough question or what? I don't know. What the hell? 2 days in a row, I was not able to solve this. Jesus. If it's this, it's all the way to I. That's it? Huh? Really? That's it? All different ways. Basically just say when you hit an operator, you compute the left and you compute the right. For every one of them, you perform. Huh? It works? Well, apparently it does work. I don't know. So we're saying we have 2, and then we'll do whatever here can produce, right? And then this will give you 2 values, right? This will give you 2 values, which is minus 10 and then minus 34. But hold. And then with 3 minus 4 times 5. So it will be 3. And it'll be 4 times 5. Right? It'll be 3 and 4 times 5. So we do the minus. So 4 times 5 is 20. Right, that's minus 17. But if you do this, it will keep going. So you do 10 times. Then do everything on here. That's minus 5. Yeah? Then you move on to the minus sign. So you say everything on the left, that's on the left. Right, and everything on the right. That gives you minus 14. Then you do this, you focus on this, and you have the left. Oh, what the hell? Yeah, my ability definitely dropped because previously I think I was able to at least solve this, but now I can't. I was at least able to. Whatever this is, I was able to get it right. But this time I can't even get it right. I was trying to do recursion, but the recursion, right, it didn't work. Wow, 2 days in a row. That was rough. Because it's multiple sign, multiply sign. So we focus on the sign. Yeah, but if you think about it, we are saying different way of grouping, right? So if we have different way of grouping, we're saying that there will be a final operation. We're just looking for the final operation. The final operation could be this times, right? The final operation could be this times. And the final operation could be this minus. It just turns out when it's this minus, the final operation is, oh man. Yep. You just do that. Shoot. It probably can cache it though. Yeah, I think it can cache. Yeah, I think it's like a two level cache. You can probably cache it. Oh man, this is tough. 2 days in a row. Damn it. Different way of grouping. Man, I'm unhappy. Very unhappy. 2 days in a row. What's even worse? I solved both of them the first time, although those solutions were not optimal. Okay, I was trying many recursion ideas, but I either end up with one fewer result or one more result than the expected answer. And I was stuck at how the recursion should be. I then try to find a way to like thoroughly add parentheses. And that turned out also very difficult. What I didn't do was analyzing based on the operator. See what the key idea here is that no matter how you group, right, the number and operators, there will always be one operator, right? One operator that is executed at the end. Using this, right, as the constant, right, as the constant anchor, we can exhaustively divide the expression, right, into the left half and the right half. Yep, that's that. So we definitely need a memo for this. Right. All right. At least let's code it. Okay. We need int memo. Okay. And then we need a private DP. What we need is low, high, expression, sure. Low, high expression, yeah, that's it. I set everything into. What do I set everything into? Oh. There's no value I can set it. Well, I can set to maximum or minimum. Because it says, I know it's a number of different results. Yeah, I think I can set maximum, minimum, right? So I can say, let's just say maximum. We say if this dot memo low and high, right, low high is smaller than integer max value. Now we just return this dot memo low and high. Right. Otherwise, then we have to do it. How do we do it? So we go from low to high and then find the first thing, right? We took it out and say string exp. Now operate is just plus, minus, multiply. Right. How do we say string contains? In -1, it does not exist. Okay. Yeah, so I can do that. Oh, actually, I don't even need to do this. I just go through, and then we find something, we do the left, we do the right. Oh, what is this? This is not right. This is not right. It's not a single value. It's a list of values. Holy crap, a list of values. How do we do this memo then? Well, since it's only 20, because otherwise it's going to be, I don't even know what it's going to be. Yeah, I actually don't know what it's going to be. So, yeah, how do you memo it? Still memo. List of integer. Oh shit. List of integer this. List of integer. This is yes, list of integer. I didn't realize. Yes, that means it's a list of integer. Okay, that makes sense. Which means this has to be a list of integer. Man, I feel like my ability is dropping. I can't even figure out the list of integer part. Then we can say if it's dot is empty, right? So we say if it's not empty, that means we have done it before. Then, oh man, this is terrible. Okay, so now it's not empty. And then I can say for int I equal to 0, I smaller than equal to high I plus plus, right? For int j equal to, no, that's not right. What we do here is we check if expression dot char at I is equal to plus. Then we do something. Operator. Operator function. Is there a function? What are you trying to do? I can do it myself. I can say plus private op int op. We have char operator int a int b, right? There you go. If char is equal to plus, return a plus b. If char, oh, I'm gonna switch operator case. If it's plus, I'll say return a plus b. Don't even need this. Case multiply, return a times b. Case minus, return a minus b. Default. Go ahead, erase, throw. I don't know. I don't know how to throw. Return 0. Should not reach here. Okay, so we have the operator. And then we can just say if it's equal to, okay, we can just say if it's larger equal to 0 and expression dot char at, we can just say char c equal to expression dot char at I, right? And then we can say c is larger than this and c smaller equal to 9. Continue, right? Else, okay, and then I can say for int last value of dp low to I minus 1 expression for int right value dp I plus 1 to high. Oh, we need a result. Result is just memo. Okay, so we can say memo this dot memo low to high dot add operation c left value and right value, and we'll return this dot memo low high. Okay, at least we got this done. We initialize the memo. Expression dot length, I think. Expression dot length. Initialize it. Actually, I'm not sure. Row of this memo. Can I do arrays dot fill row with new array list? Cannot create a generic array of list integer. Huh. How do you create it? How do you create it? Oh, new array list. My bad. It should be array list. Right, array. Actually, I don't know this usage. Array list something something. Okay. So array list. Oh. So you have a new array list, and then I have to. Do I have to? Actually, I don't have to initialize it, right? I don't think so. I don't have to initialize it. So I think this is good. New array list. Actually, I'm not sure. But we can call dp 1 from 0 dot length minus 1 expression. So kind of just say to return this. The expression of needs unchecked conversion to conform. I don't know what that means, but let's run it. See if it makes any sense. Not even sure if it will pass. Oh, that's not valid. Wow, 2 days. Both end up is null. Oh, I see. If this is not equal to null, and then I can say this dot memo low and high new array list, something like that. Okay, that's interesting. Let's go back, see where we got it wrong. So if it's just a number, right? If it's just a number, then we go through this, then we never get so now we can say return the, and say if this dot memo low and high dot is empty, right? That means it's just a number. This dot memo low high dot add integer dot parse int expression dot substring low to high. Okay, let's try this one. Wait, what? Oh, wait, hold on. Wait, how is it possible? 2 and 1. Oh, 0, low. That was bad. So bad. Yeah, it's O(n) times 2 to the n. I don't even know what to say. It's like, damn, 2 days. I need to do something to boost up the confidence. Anyway.